Hi everyone, this is Caroline Kiltica from AASHTO and welcome to today's Go Tug webinar. Before we get started, I'd like to go over a few housekeeping items. If you called into this webinar and did not put your audio pin, you are muted. So if you did not put your audio pin in, you will not be able to speak at the end if you have questions. So please put the audio pin in. Second, questions can happen at the end. We'll be taking all questions at the end of the webinar. You can either raise your hand in the webinar function in the grab tab and I can unmute you to speak, or you can also put your questions into the chat box. One last item, if you're dialed in via telephone to the webinar and you have to take another call, please do not put this number on hold because we will then hear your hold music. If you need to take another call, please drop off this call and then call back in. Okay, so we'll begin with the webinar, and I have a couple slides here before we get started. So this is our agenda. We're going to do just a quick welcome and overview. We're going to have two technical presentations. The first, the use of Leaflet at USGS and GTOC, and second, Mississippi DOT's approach to developing interactive maps. And then it'll be followed by a Q&A session. I just want to say that AASHTO is not endorsing or promoting any brand of products. These webinars are for information sharing purposes and are open to all tools. If anyone is interested in presenting or has an idea for a webinar topic, please contact Penelope or Jeremy. So we'll just give a quick history and the future for Go Tug. So the key people in this group is our chair, Jeremy Aycock from North Carolina DOT, and your AASHTO liaison is Penelope Weinberger. So what is Go Tug? Go Tug is a geospatial online transportation users group. It began as an AASHTO Innovation Initiative, and it was initiated by Utah DOT. AII project was a working group under the Standing Committee on Planning, Subcommittee on Data. Now Go Tug is part of the Committee on Data Management and Analytics. So this work group will provide ongoing support and development of transportation agency capabilities regarding comprehensive GIS-based online collaboration platforms. And listed here is the Go Tug Steering Committee. So why Go Tug? It maintains the momentum started within the UPlan AASHTO Innovation Initiative, and it marries business needs with innovative web-based geospatial solutions. So here are some Go Tug resources. We have the AASHTO technical resources. Here's a link for our website and a new distribution list. For information, you can sign up yourself. There's the email address, and then we also provide webinar services. And for the AASHTO Data Committee resources, the committee increases the visibility of GIS and geospatial data issues in technical resource group for all AASHTO members. All this information will be emailed out after the webinar to all members who have joined today's webinar. So the next Go Tug activities, so we have the upcoming two webinars. The first webinar is September 4th, data governance, and the next webinar is slated for December 4th for GIS in design. So our first presentation is the use of Leaflet at USGS and GTOC, and our presenter will be Robert Jershai. He's a project manager of the Delivery Development Team at the National Geospatial Technical Operations Center based in Denver, Colorado. They're in business of delivering geospatial data and services to the public. he will be presenting on this. So I'm gonna switch over screens onto Robert, and he will present.
All right, thank you. Thanks for the introduction. So, hello everyone. My name is Robert Jershai, and I'm a project manager for delivery group here at the National Geotechnical Operation Center with USGS here in Denver, Colorado. So first, I'm going to go a little bit of an introduction of who we are, what we do, and things like that. So we're obviously under USGS, under Department of Interior. We have several innovation teams that span between two locations, Denver, Colorado, with a Science Systems Development section, and Rolla, Missouri, with the Information Systems section. I'm obviously located in Denver, and we have 4 teams here. I'm project manager of delivery team, but we have other teams as well that I will be presenting some of their products. We are in business of delivering geospatial data and services to the general public. My team consists of 2 GIS developers and 3 web developers. We're kind of fluid team. We're still trying to figure out where we actually are in the food chain, and we're trying to figure out how to build modern applications based on open source technologies and how to serve it in the cloud. So we're in business of maintaining the national map, services and applications. We have 2 flagship applications, TNM Viewer and the TNM Downloader. And as far as TNM services, we have 7 plus service zones that we're currently serving in the AWS cloud. Currently, we're focusing on the infrastructure itself. We're trying to get better. We're trying to create applications that are scalable and accessible to everybody, and that's something that we're heavily investing in AWS CloudFront. So, why Leaflet, right? First of all, a little bit of a background. I used to be a developer, and now I'm a project manager. And back in the day, and I'm talking about 2013, 2014, I think that's when Leaflet came out, and it was a breath of fresh air, to be honest with you. It is open source. It was so easy to start, pick up the library, start using it, and start extending the functionality as needed. At the same time, it's a very lightweight compared to our applications that are heavily rely on Esri, JavaScript API, and Dojo. And it was very easy to pick up. It was vanilla JavaScript, and ecosystem was very healthy, and it currently is very healthy. And we've also noticed that Esri is also embracing it as well with Esri Leaflet plugin, which I will be touching bases on later on. So our first application is a TNM Downloader. I'll just talk a little bit about it. It's created in 2014. At the time, Backbone.js was very popular. We've used Backbone.js framework to create the whole application. It does have a tight integration with Leaflet. It's a map-based application, so map is very dominant, as I will demo later on. It uses few custom Leaflet plugins. Some of them are open source, some of them are in-house. It is built on Java backend, so all of our APIs are running in Java, and it's ready for revamp. I know it's only been like 5 years since we've been using it, but it's ready for a fresh revamp using modern day technologies like React or Vue or things like that. And hopefully we'll do that in FY 2020. So I will break out here just to show the application here really quick. As you can see, it's very map-centric. So what this application allows you to do is allows you to download to see all the data offerings that we offer. For this case, I've picked one of our very popular data sets, which is the elevation source data, 3Depth with the LiDAR. And you can see the choices that we have to offer to our customers. Okay, and Murphy's Law. Actually, probably I wouldn't be able to demo this completely because we're working on updating our underlying hardware. So I apologize, but I will talk a little bit about the application itself. So it's just like I said, it's a backbone application. It's a little bit dated, so we need to revisit this. It's very map-centric, which means that we need to have everything is controlled by map, and our focus is going forward, and the reason why we're using Leaflet is that it needs to be mobile friendly as well. We know that Esri JavaScript API has also started becoming mobile friendly, or already is mobile friendly, but it's a little bit heavy, and we needed something that's very lightweight that will work on mobile devices, iPads, and obviously desktops. So next two applications will work, I promise. So the next one that I want to talk about is the TNM Core. Back in the day when I was a developer, I was actually involved with building this application. So what is the TNM Core? It's a crowdsourced mapping project that relies on volunteers to assist the USGS by collecting and editing features from structures. It has been created in 2014. Again, heavy use of Leaflet with Esri Leaflet plugin. It has a .NET backend, and it's a vanilla JavaScript, so no frameworks, because at the time we haven't used any frameworks. And one of the main things that we're using is the data tables library that was extremely popular at the time. So going in there, it's open to the public. So I will just log in really quick. And basically what it allows users to collect structure points. This is powered by Esri's services, but again, we want to kind of break away from Esri on the client and to try something new, and that's what we did with Leaflet. Now, I say break away from Esri, however, we ended up using their open source software, which is Esri Leaflet. And we've actually submitted some portions of the code that we extended here. We submitted back to the community. Basically, what this application allows you is, and I'll zoom in actually to where we can actually start seeing what these are. So these are all the collection of points, whether they're schools, fire stations, police stations, hospitals, and so on. Users are able to pick the point, change the name if the name change happened, or move it based on the move the location of it. If let's say a school closes and reopens somewhere else, we were asking public to help us track this data set. What you can see here on the screen is I can see some of the updates. So basically how it works, we don't just let anyone edit things. We have a tier approach. So if someone edits something and it triggers our we call it magic filter, it triggers some kind of filter or reason why we need to review this manually. We show this to our administrators, and they approve or reject, and they preview the issue, and then they can see who the editor is, and so on. So basically, we've decided at the time to do something that hasn't been done before. We've decided to open ourselves to the public to grab this information and use the public to help us curate the information that is presented. The next one that I have to show is the Markup app. So another application that is based on a similar platform as the TNM Downloader. Again, all of these applications use Leaflet. This application allows users to send in markups or editing recommendations over the NHD high resolution, and WBD features. Then NHD team and Hydra folks pull down said markups into various applications to include them, approve them, reject them, and so on. This has been created in 2015, very similar like the previous one. It's Leaflet, based on Leaflet on the front end, vanilla JavaScript, so no frameworks, heavy use of data tables, and .NET on the back end with a custom Esri-powered feature capturing workflow, which is the circle of life. Again, we don't allow users to change the data, right? So we let them work on the copy of the data, and then we we automatically, through Circle of Life, push that data in the master database. So I'm going to break out really quick for a demo. As you can see, it's fairly similar like the previous one. What I'm going to show you here is all the markups that have been done with the tool. As you can see, East Coast is more popular than us in the center or even the West Coast. Basically, the workflow is pretty how should I say, map-centric. So what I'm going to show here, and just since this is regarding NHD and WBD features, I'm going to just show the NHD features that users can modify, or again, this is a markup app, so they provide feedback for the data that we're seeing on the screen. So you have two options. You create a new feature where the feature is missing, or you need to pick up the existing feature. So I'm going to do water body here really quick, start identifying. And then you can pick the feature found, and then you can select what you want to do with that feature. You can read through it, and you can say, oh, I just want to modify the attributes. The actual geometry is fine, and so on. I'm not going to do any of this because I don't want to mess with this is the production data. So, but what I want to show is that for this particular application, we've extended and created like custom widgets that we're using. So that's the NHDW, the identifier that will allow users to interact with map and so on. As far as the application itself, we've noticed that stability of the Leaflet platform is amazing. Again, I cannot stress out how important it is for us to be able to create custom plugins and extend the functionality of the application itself. So a Leaflet is awesome in that field. And back to this, what I next want to talk about is a little bit of the Esri Leaflet plugin. Again, I believe this started in 2013, and in 2014 we kind of jumped on board. At the time, we had a couple of developers, myself included, that decided to actually go ahead and extend their library and help them out to match all well, not all, but majority of the tools that we can use with the JavaScript API, Esri JavaScript API. And it's been a very great it's been a very great collaboration for us. We've released most of these updates and pushed them to the public. So if you go to Esri's GitHub.io page, Esri Leaflet, you can see in the examples, and actually I'm going to click on that really quick. You can see how easy it is to just open up create your custom application using Esri services. The part that since we were doing a lot of feature editing and whatnot, we've submitted some bugs and extended some functionality for the feature layer plugin and the image map layer. So it's pretty amazing what the community can do if we get together, and we are all about giving this back to the community. That kind of concludes my presentation here. And if there's any questions, we can talk after the second presentation. Thank you.
Fantastic. Thanks, Robert. So as we switch over to our next presenter, I'm just going to say a quick housekeeping thing. All the presentations that our presenters are talking about today are included for download on the Handouts tab, which is located on your webinar panel. I believe it should be the second from last or one of the tabs that are on the panel. So they're all available for download and will also be available on the GoTug website tomorrow. All right, so I'll introduce our next presenter. Our presenter is Michael Cressa. He's a professional engineer with the Mississippi Department of Transportation. He currently serves as the director of the Transportation Information Division, where he manages the department's GIS activities. His presentation today be an overview of Mississippi DOT's approach to developing interactive maps. He'll discuss the user expectations, the open source data publishing solution, and the leaflet map functionality. And Mike, you should be ready to go.
All right, thank you. And great presentation, Robert. That was really good. Okay, so really where MDOT started with this whole process was really at the very beginning trying to come up with a way for us to develop and really build out our mapping technology and the ability to visualize a lot of the data that we had been collecting over the years and trying to really just get MDOT's data out to the resources. But early on, the problem we had was the fact that our IT department really would not buy into that because they felt like, they just really didn't have any familiarity with being able to build a map tool or being able to take spatial data and present it in a map. They just really didn't have very much experience in it, and it was really hard for us to explain what the anticipated outcome was for a lot of these applications because they had no spatial data background. They had no way of really understanding when we started talking the GIS talk, they really didn't understand what we were really asking for them to deliver to us. So the very first maps that were built, we really ran into a lot of problems because they were all built with deprecated technology. You had to run something like this Microsoft Silverlight. If you would go to one of the sites and click on it to look at the map, if you had not already downloaded and installed the Silverlight, you were always getting this little icon here of, hey, you need to go and download this first. But then over the years, it really became a problem because of the browser incompatibility. We had some users trying to invoke that through Internet Explorer, some trying to do it through Chrome, some trying to do it through Safari or others browsers, and it just really became very difficult to manage that whole process because every one of those browsers handled Silverlight and some of those earlier technologies differently. So in really going through this and trying to come up with a solution, one of the things that our IT department really was wanting us to do was to look at trying to use Google as a Google map, as our base map, and put data on top of it. And this is an example of one of the Google maps that we had built early on, obviously using the Google API. The problem with this map is that it doesn't give enough information that we want to see on a map. You're stuck with Google's base map. You're not being able to use any of the underlying data that MDOT has, for instance, like a county feature. Early on, when Google was publishing maps, the API for that was really hard and almost impossible to get a county representation of Mississippi. So when you start looking at a map like this, and you know, the DOT, a lot of things that we do, we think in terms of counties. We have 82 counties in Mississippi, so when you start asking someone for information in Hinds County, it would be nice to be able to see where that county is on the map. So we started here in Transportation Information Division, we really started trying to find out what the users really wanted. What type of an experience did they really want with maps that we were building or trying to build? And obviously, the first thing that always came up was the fact that they all wanted the Google experience. They all wanted that look and feel. They wanted to be able to just click on a map and roll the mouse wheel down and zoom in, zoom out. You know, the OpenStreetMap is another map that was becoming very popular at the time when we were discussing all of this, and both Google and OpenStreetMap both are the Slippy map technology, where you can really zoom around on the map real easy with a mouse. They're very fast, they're robust. You can put data on top of those maps, and you can have some defined but the problem is you can't put a lot of the MDOT internal data on those maps, and we'll talk more about that in a minute. But also, the other thing that they really wanted was user-defined symbology, and you know, when you start trying to use those APIs, sometimes that becomes difficult. Also, programming around some of those requirements that the API has. Software interoperability, that's one of the things that we really wanted, and also flexibility for data formats. We wanted to be able to pull data in from various formats to be able to use that data inside the map itself. So some other things that we wanted to consider when we started looking at what we were trying to achieve here was, obviously, we wanted a low-cost solution. We also, here at MDOT, we are not an Esri shop. We actually store all of our data, all of our GIS data is in Oracle, and we are really, at that point, we have various tools that we use to manage that data. We do have Esri, and we do use Esri, but we also have Intergraph tools, and we also even use QGIS at times. So we are really, I like to say that we're sort of agnostic when it comes to the type of software, type of tools that we use for our GIS and how we manage our GIS. The idea of a standalone API was sort of intriguing. We wanted to be able to build something that we could use throughout the agency. We wanted something also that would be compatible with mobile devices. We wanted to be able to build this in HTML5 or something similar, so that we could go cross-platform from Internet Explorer to Chrome, and also from desktop computer to a mobile device. And the idea there being we would write it once and run it anywhere. So in looking at the products that were out there and available, first one we looked at, obviously, was Google Maps. We were already using it. And Google Maps, it's copyrighted data. You're using an API, and that API is Google's. It's not yours. You can't. The data that's behind that, you can't manipulate that data if you see a problem with it. The agencies, they have different organizations that supply data to them, and really it comes down to the fact that there's no guarantee of the accuracy of the data. We had numerous times had found problems with the road network that they had in Google that they were presenting on the map was not accurate to what the road network actually is out there in the field. And also OpenStreetMap. We looked at OpenStreetMap. The problem with OpenStreetMap is it is a wiki style process, and the problem with that, I mean, there's good and bad to that. The good is you would be getting a lot of updated data. The problems with that is exactly what the statement is over there on the right. The database will always be subject to the whims, experimentation, and mistakes of the community. So we felt like that we really wanted more control over the base map and the data that's behind the scenes. the road network and other things that are there. So these two tools really were not going to give us that. And that's really what it came down to, is the fact that the base map data in those maps is not our data. It's data that they wanted to put out there. And we felt like we wanted something that was a little more accurate than that. So at that point, what we came up with is a open source solution called GeoServer. Now, what GeoServer is a data publishing solution that we use now to build all of our WMS and WMTS and WFS services that we use throughout the agency. This is a very powerful tool. Like I said, it's open source. You can load data directly from Oracle into this. It will read numerous data types. I've got some, let's see, the output. It has the WMS output formats, or I've got listed here KML, GeoTIFF, JPEG, PDF, PNG, and there's many others. And also, the data sources are either vector or raster data sources. And so over on the right here, you'll see a list, and that list is the vector data and the raster data sources that you can pull data in from. So if you notice under the vector data sources, you can pull in shapefiles, you can pull in PostGIS databases, you can pull in Oracle databases, and you can also pull in other web feature services. The raster data sources, there's numerous of those also there that you can pick from. It's a very powerful tool. And the fact that you can bring this data in and then create the WMS and WFS services from that data. Okay, so one of the things that I found challenging when we first started GeoServer, and I just wanted to mention this, was how the data is organized inside GeoServer. So there's a workspace and a store or store name that they have, and the way I started looking at this was that a workspace is like a category, and a store name is going to be the actual database that it's being pulled from. And those are our production databases there, different ones that we're pulling the data out of, which is like a schema out of the database actually. And then the workspace, what I was trying to do was categorize the data in such a way that it made sense when you indexed it, and would be able to look or search through the information easier to find the data that you're looking for. Because once you start building these maps, the data sources, you get an enormous, large amount of data sources involved in this. So one of the other things that GeoServer allows is styling of the map data. And when you start building some of the tile sets that you build for like the WMTS services. When we first went through this process, we were building the styled layer descriptor, the SLD formatted styling, which is by default the way GeoServer, the documentation and everything, that's how they really explain how to build the styles that you build. Example here that I have on the left of this table, on the left side is the SLD formatting for formatting a field polygon where the area has, for like a county that has, or excuse me, a city that has a population of less than, 2 million. And over on the right is the equivalent CSS formatting, which is cascading style sheets. So it's only literally 4 lines of code. and you could probably reduce that down to even 3 lines. So when you start styling large data sets, it became very obvious real quick that we needed to be using the CSS formatting instead of the SLD formatting. So this is just an example of the equivalent formatting between the one data set being styled the exact same way with 2 different forms of code. And so currently what we have moved to or transitioned to the CSS formatting for most of our data sets. Okay, one of the other challenges that we had early on was trying to represent our road network the way that we wanted it to look as realistic as possible. And one of the things that you can do there is you can have this attribute that's called Z order. And the Z order allows you to stack features on top of one another. And if you can see in this particular map on the left, the lines are all connected. They're interconnected to one another in most places, especially the red lines. But over on the right, where the Z order is enabled, the Z order tells that red line that's running sort of it'd be from the west to the northeast, that it does not connect to those lines underneath. So what you wind up with is the ability to visualize roads that are over other roads and that are not interconnected. And that was a big thing, a big sale for us, because we wanted to definitely make sure that we understood how our network was tied together. We definitely wanted to be able to visualize on the map what roads were over other roads. The same thing with the railroads, so that you knew that that railroad was over our highway or was it under our highway. Okay, so at that point, we had pretty much everything built out inside GeoServer. And what we did was we actually built tile layers and got our tile layers. So we built a base map that has water features, it has our county features, it has our road network, it has the railroads, it has the bridges, it has all of that information tied to it in just our base map itself. And this is an example of what that map looks like once we bring it into Leaflet and put it into actual browser. You know, the Leaflet, we've already talked a little bit about Leaflet, but it is an open source JavaScript library. It is mobile friendly. You can building using the Leaflet and let's see, we're actually using this inside Visual Studio and using .NET, and we get a HTML5 compliant map when we get finished with this. The applications are all mobile friendly. The provider for this, it's an agnostic. We can, you know, whoever we want to provide the data, we can use that data. The Leaflet is very extensible. There are many plugins out there that are available for you to be able to do a lot of different things. There's a lot of documentation on Leaflet. And it has a well-documented API that you can use also to your advantage. So this may look a little washed out. I tried blowing this up a little bit. Example of the map. Again, one of the things is it's got this layer control. The layer control allows you to be able to build in a little bit of control on how or what is being displayed on the map at the time. So what we have here is we found a way to categorize our data. So we have a base map, and we call it our MDOT base map. But as you see here, we still are allowing the users to switch to like an OpenStreetMap or even a Google Road Map. And then also we're taking advantage of Google's satellite imagery and their hybrid imagery, and its imagery and their road network, so that the users can switch back and forth between the background layers or the base map layers with all of that. And also we are able to pull in like Mapbox imagery. This is the NAIP imagery here that we have. And then down here at the bottom, the overlay maps, those are all added features that we've built on top of the map so that we can, you are able to turn those on and off as needed. But it just gives you a little bit of an idea of how flexible Leaflet is in allowing you to build the legend or in order for you to build the map to look the way you want it to. So what's next? The next thing that we're looking at currently is vector tiles. Vector tiles is a new way of presenting data to the user. The rendering is done by the client. It allows the applications to be styled differently because you're styling them on the client side, not on the, like for instance, the way we're doing it on the GeoServer side. You're actually doing it in the application itself. The file is smaller than an image tile currently, what I mean by that is the entire file is smaller than a single image tile, which means it's a tremendously small file that you're moving across from the server to the browser across the network. So it creates a much faster data transfer and a very much lower bandwidth usage on your system. The one disadvantage to this is the fact that it will require us to move to open layers instead of Leaflet. But open layers is another open source JavaScript library. Currently, Leaflet does not handle vector tiles. I anticipate that happening soon. But again, it's based on demand and how much the public wants that to be a part of Leaflet. If that happens, they will code it and it will become part of the system. The other thing that we've been looking into is load balancing GeoServer. You can take GeoServer and you can distribute it across different resources, so you can have multiple instances of GeoServer running at one time, which will allow you to handle workload. You could be able to serve up the image requests from multiple GeoServer instances at one time. This is really called GeoServer clustering, is what it is. And what we would be using for that in our case is a tool that's called Nginx. That is the load balancing tool that we would put on. It actually sits between the server, the server and GeoServer, and it would be allowing GeoServer to distribute the work across the system. Okay, at this time, that's really the end of my presentation. But what I wanted to do is I would like to just demonstrate just a few of the maps that we have, if I've got time. So here, this is a list of several of the different maps that we have available that we've been using. The one that I would like to show you right off here up front is the erosion control map. So here it's the DOT. We have an erosion control inspection program where they go out and inspect construction projects. Well, this map is it's showing you the actual deficiencies that were encountered on sites. This is live, so as soon as a inspection is done, the deficiencies show up on the map. So if I roll in, you can see the map is very responsive. The roads here that you see are our this is our LRS. So this is an exact copy of the data that we have that we're submitting for our road network. So as I go in here, you can see these points come in. I can click on the point, excuse me, let it load. And what it's loading is, so we have photographs that we're taking at this site. This is documented. This is a deficiency, and it was because of a filter stone rock check problem. It was not installed and it needed to be reinstalled. But these images come across and show you the problem at the site. The map, again, like I said, is very responsive. We can move around. Come down to show you a little bit more about the map itself. Right here, where we zoom in, here's an example of the road network with the Z order. This ramp, this white line here, is a bridge, and it goes over Interstate 55 and Interstate 20 and ties back in. So you can easily tell that that's a bridge because of the black markings on the outer edges of the line work. And then you can also see that it does not connect to 55 or Interstate 20 in this case. Just an example of the Z ordering and how that works. Same thing here. You can see that ramp goes all the way over 20 and all over 49. Okay. So let's see. This map or this application is a hot mix asphalt plant location application, and we have it's just a database basically of all of our hot mix asphalt approved plants that we have in the state and that are used on contracts. But also what I've done is I've built a map interface with it that brings in the ability to take the data and analyze the data. For instance, this is a project that if you look, I'm pulling this data out of our site manager system, and it's telling me that 85% of the installed bid quantity has been installed, and that is actually being supplied from this plant here. You would think that plant there, the Dickerson Bowen plant, would be the one that would be producing that asphalt, since it's right in the back door of this plant project. But actually, it's being supplied from the APAC plant. You can also click on the plant itself, and you can see the projects that this actual plant is providing asphalt for. This is just a map, just a very interactive map that shows you the projects that are being worked on, and there's no current on that one. Here's one that's they're a little over on their bid. You can see it's 112%. So they placed a lot more asphalt, or somewhat more asphalt than what they had bid on the quantity on the project. Okay. At this point, I'm really finished. If anybody has any questions, I guess I'll turn it back over to you, Carolyn, and you can handle the questions.
Fantastic. Thanks, Mike, for the great presentation. I'm just going to quickly go through this so you guys can see my screen. So we'll start a question and answer period. If you guys have any questions, we have our GoTug committee member also on the line, Nicole Hansen, to help with the questions. If you have a question, please type it into the question box. Or, if you put your audio pin in, you're more than welcome to unmute yourself and ask the question. Or you can also raise your hand on the webinar panel, and I would be able to unmute you. So I will wait for questions. I'll give it a few minutes if people are typing. All right, I don't see any questions popping up in the question box. Oh, let's see. First, we had a great presentation. Thank you. I am not seeing any questions come in. Just a housekeeping note, if anyone has additional questions on the presentation, the contact information is included on the handout section on the right hand on your webinar tab. And you can download that, and they will also be posted on the GoTug website. All right, we have a question for Mike. What tool did Mississippi use to generate the tile cache?
Tile cache?
The tile cache, you use GeoServer to do that. It has its own, it's called GeoWeb Cache. It's built into GeoServer. You can go in, build it through the application itself, or the way I prefer to do it, it's in the documentation, you can actually go in and do by command line and send off a process, and it will tile the features for you. It has all the layer capability. You can change the tiling grid. It has you can build your own custom tiling grid, or you can use the tiling grid like the one I used is a Google, the Google version that's already built into GeoServer, and it's a very powerful tool.
All right, thanks. And then we have another question that popped up. Have you ever compared performance of GeoServer with Esri's ArcGIS server?
No, I have not. I do know that we're using this throughout the agency and externally. We have several maps that are built on our external site that are using GeoServer, and so far we have not found any performance problems with the tool. The one thing that we were thinking is that we would have to go ahead and do the load balancing to accommodate any loading requests or problems that we've had. But honestly, we've not run into any yet. So we're not, at this point, we're not even looking into doing the load balancing.
Okay, great. I'll leave it open for any other questions that have come through. Alrighty, I don't see any other questions coming in or being typed. So I guess that we can end it there unless Mike or Robert, you have any additional comments, or Nicole.
This is Robert, so thank you for the invite. Really appreciate it.
Yes, this is Mike. Same here. Thank you for asking me to do this. And if anybody has any questions, you can feel free to contact me.
Fantastic, and thank you guys so much for your time in joining our webinar and giving fantastic presentations. Like I said before, if you need the materials in the presentation right at this moment, they're included in the handout tab on the webinar panel. And the full webinar has been recorded and it will be posted on the GoTug website and sent out to those who attended today. With that, thank you so much for everyone's participation.
And we'll see you guys in September.
And yes, and we'll see you in September 4th. Thank you.
Thanks, bye-bye.